Welcome to Math Tutorials. In this video, we are solving every question of exercise 2.2 of Chapter 2, Inverse Trigonometric Functions, from the NCERT Mathematics textbook for Class 12, Part 1. Exercise 2.2 has 15 questions in 3 groups, 2 identities to prove, 5 expressions to write in simplest form using clever substitutions, and 8 values to evaluate. Here are the questions. Let's start with the first proof. Question 1, a proof. 3 times sine inverse of x equals sine inverse of 3x minus 4x cubed. The restriction of x to between minus 1/2 and 1/2 keeps everything inside the principal branch. Substitute. Let theta be sine inverse of x, so x is sine theta. Now use the triple angle identity. Sine of 3 theta equals 3 sine theta minus 4 sine cubed theta, which is exactly 3x minus 4x cubed. Take sine inverse of both sides. The range restriction keeps 3 theta inside the principal branch, so sine inverse undoes the sine cleanly. Question 2, the cosine twin of question 1. Here x lies between 1/2 and 1, again protecting the principal branch. Substitute, let theta be cosine inverse of x, so x is cosine theta. The cosine triple angle identity. Cosine of 3 theta equals 4 cosine cubed theta minus 3 cosine theta, that is 4x cubed minus 3x. Take cosine inverse of both sides. The given range keeps 3 theta between 0 and pi, so the inverse peels off cleanly. Question 3, the first simplest form problem. The square root of 1 plus x squared suggests a tangent substitution. We simplify the whole expression to a single inverse function. Put x equals tan theta, then root 1 plus x squared is sec theta. The fraction becomes sec theta minus 1 over tan theta. Write everything in sines and cosines, and it collapses to 1 minus cosine over sine. By the half-angle identities, that ratio is exactly tan of theta by 2. So the expression is tan inverse of tan theta by 2, which is theta by 2, that is, 1/2 tan inverse x. Question 4. A square root of 1 minus cosine over 1 plus cosine, the half-angle identities are built for this. X lies strictly between 0 and pi. Replace the numerator and denominator with their half-angle forms. 2 sine squared x by 2 and 2 cosine squared x by 2. The square root of tan squared is tan itself here, since x by 2 is in the first quadrant where tan is positive. So we have tan inverse of tan x by 2, which is simply x by 2. Question 5. Cosine minus sine over cosine plus sine, dividing through by cosine, will reveal a tangent difference pattern. The range keeps the final answer inside the principal branch. Divide numerator and denominator by cosine x. Recognize the compound angle formula. 1 minus tan x over 1 plus tan x is tan of pi by 4 minus x. The given range puts pi by 4 minus x inside the principal branch, so tan inverse undoes the tan. The answer is pi by 4 minus x. Question 6. The root of a squared minus x squared calls for a sign substitution. X stays strictly inside minus a to a. Put x equals a sine theta. The root becomes a cosine theta. The fraction is then sine over cosine, tan theta, and the a's cancel. Tan inverse of tan theta is theta, and theta is sine inverse of x over a. Question 7, the last simplification. And the numerator 3, a squared x minus x cubed, is shouting the tangent triple angle formula. The range on x keeps 3 theta inside the principal branch. Put x equals a tan theta, and divide top and bottom by a cubed. That is precisely the triple angle formula for tangent, tan of 3 theta. So the expression is 3 theta, that is, 3 tan inverse of x over a. Question 8, the first evaluation. We unwrap it from the inside out. Innermost first. Sine inverse of 1/2 is pi by 6, so twice it is pi by 3. Cosine of pi by 3 is 1/2, and twice that is 1. Finally, tan inverse of 1 is pi by 4. Question 9. Both fractions inside are famous. They are the tan half-angle forms of sine and cosine. The conditions on x and y keep every substitution inside its principal branch. With x equal to tan a, the first fraction is sine of 2a, so its sine inverse is 2 tan inverse x. Likewise, the second fraction is cosine of 2b with y equal to tan b, so its cosine inverse is 2 tan inverse y. The half kills both 2, leaving tan of tan inverse x plus tan inverse y. And by the addition formula for tangent, that equals x plus y over 1 minus xy. Question 10, and a classic trap. Sine inverse of sine of 2 pi by 3 is not 2 pi by 3. 2 pi by 3 lies outside the principal branch of sine inverse, which only spans minus pi by 2 to pi by 2. But sine of 2 pi by 3 equals sine of pi minus 2 pi by 3, which is sine of pi by 3, and pi by 3 is in the branch. So the answer is pi by 3. Question 11, the same trap with tangent. 3 pi by 4 is outside tan inverse's branch. The principal branch of tan inverse is the open interval minus pi by 2 to pi by 2, and 3 pi by 4 is not in it. Tan of 3 pi by 4 equals tan of 3 pi by 4 minus pi, which is tan of minus pi by 4. Minus pi by 4 is inside the branch, so that is our answer. Question 12. A sum of two inverse angles inside a tangent. We convert each to a tangent first. Sine inverse of 3/5. In a 3-4-5 right triangle, the tangent of that angle is 3 over 4. Cot inverse of 3/2. The tangent of that angle is the reciprocal, 2 over 3. Now the addition formula. Tan A plus tan B over 1 minus tan A tan B. The numerator is 17/12. The denominator is 1/2, giving 17/6. Question 13. Once more the branch trap. 7 pi by 6 is bigger than pi. Cosine inverse answers only between 0 and pi, and 7 pi by 6 is beyond that. Cosine of 7 pi by 6 equals cosine of 2 pi minus 7 pi by 6, which is cosine of 5 pi by 6, inside the branch. So the value is 5 pi by 6. Question 14. First, resolve the inner sine inverse, then a simple sine. Sine inverse of minus 1/2 is minus pi by 6. Subtracting a negative, pi by 3 plus pi by 6 is pi by 2. And sine of pi by 2 is exactly 1. The final question. Careful with the second term, cot inverse of a negative number. Tan inverse of root 3 is pi by 3. Cot inverse of minus root 3. The branch is 0 to pi, so it is pi minus cot inverse root 3, pi minus pi by 6, which is 5 pi by 6. Subtract, pi by 3 minus 5 pi by 6 is minus pi by 2. That completes exercise 2.2. That completes all 15 questions of exercise 2.2. In the next video, we will take up the miscellaneous exercise of Chapter 2. Thank you for watching. If you found this video helpful, do like it, subscribe to math tutorials, and share it with your friends.